Namaskar. Welcome to all of you in today's this lecture. In today's lecture, we will learn about gravitation. More information about gravitation. To start this video and this lecture, I should be tell to all participants who are present in this lecture. You did not subscribe our YouTube channel. Please subscribe, like, and share. To start this video, I should more request all participants to mute their videos and audios because 100 participants has been covered this meeting. Please stop your videos, don't on your videos. So let's start this lecture series. Now I will really share my screen. Okay. My screen will be visible to all participants. I will talk in English only, in Hindi and Marathi also. To start this subject of gravitation, first we have to learn more information about gravitation. What is gravitation? You know who has find this gravitation? Sir Isaac Newton. In to goes in more about in this story, we should have been not on all information about and gravitation because this is an basic of this. That's why we have to go firstly in gravitation. Many people says that the Sir Isaac Newton was sitting in downward of the tree. Down of this tree, the apple comes down and fall on the land or in downward. Why that apple comes down in circular direction? Why it does not go in perpendicular direction? It's all information and notes was being written by Sir Isaac Newton. He gives and he studied and more information about this gravitation, and then he find this concept of gravitation. Sir Isaac Newton has been found and three laws of this we have learned in previous lecture. In today's lecture we will learn about Kepler's law, free fall, circular motion and centrifugal force, and Newton universal law of gravitation, and also acceleration due to gravitation force of the earth. Okay, now we will go in first point, force and motion. What is meant by force and motion? In linear state, we says that we have seen that the force is necessary to change speed as well as the direction of the motion of an object. It is called motion of an object. Now next point, second point is centrifugal force. What is meant by centrifugal force? I have screen of that. I will be share my screen. Oh yes, centripetal force. It has an formula of this centrifugal force that we says that a force act on any object moving along to its circular direction towards the center of the circle. It is called an centrifugal force. Many simple definition of the centrifugal force. I will be read once again this definition. Definition is that a force act on any object moving along to at its circular direction to the center of the circle. It is called a centrifugal force. It is very simple definition. For this centrifugal force, I will be tell 2 to 3 lines of this centrifugal force. That from the activities we says that it questions and learn from a moon to go around the earth. The most of the force of attract on the moon force it towards be attracted by the earth, which attract the moon towards itself. Similarly, the sun may be attract the planet including the earth towards itself. we will be take one example, that moon and the earth. Consider we are the sun, and consider that we are the earth, and around the earth the moon, the moon is revolving. In this state, what we learned, that centrifugal force, when any object is revolving around the circle, it moves along toward the circle direction towards its center. It is called a centrifugal force. There is an example of this. Now we will go to our third point, that Kepler's law. I should be give more information about Kepler's. Planetary motion has been observed by astronomy science and ancient time before. Galileo all observed the planet position we made with naked eyes. By the 16th century, a lot of data was available about planetary motion and the motion. Johannes Kepler studied this data, and he noticed that the motion of a planet follows the created law. He studied and three laws that we have learned in today's lecture. Kepler studied that law. That first law was Kepler's first law is the orbit of planet is an ellipse with sun of one of the foci. Once again, I will read this definition of Kepler's first law is the orbit of planet is ellipse with sun of one of the foci. It is and Kepler's first law. Now next second law is that Kepler's second law is the lining joining the planet and the sun ellipse with equal areas in equal interval of the time. Once again, I will read this definition. The lining joining the planet and the sun in equal areas in equal interval of the time. It is and Kepler's second law of motion. You will able to see my screen. In this screen you will learn about Kepler's second law. Okay, I have shared my screen. See here, you can see in the screen. Kepler's third law is that the square of its period of revolution around the sun is directly proportional to mean distance and planet from the sun. Kepler's third law is that the square of a period of revolution around the sun is directly proportional to mean distance of planet from the sun. This is Kepler's third law of motion. There are three laws of motion. Once again, I will read three laws of motion. Kepler's first law is the orbit of a planet is ellipse with its sun of one of foci. Kepler's second law is the lining joining the planet and the sun is in equal lining joining the planet and the sun equal areas in equal interval of the time. Kepler's third law is that the square of a period of revolution around the sun is directly proportional to mean distance of a planet from the sun. Okay, now our fourth point is that Newton universal law of gravitation. In 10th standard we will learn of this chapter. You can take the book of an 10th standard and read more information about gravitation. Okay, what is a Newton universal law of gravitation is that the force is directly proportional. The force is directly proportional to product of the masses, and the two object is universally proportional to square of distance between them. Once again, I will read this definition. The force is directly proportional the force is directly proportional to the product of the masses, and the two object is universally proportional to square of distance between them. Once again, I will read. The force is directly proportional to product of their masses, and two object is universally proportional to product of square of distance between them. It is very simple to remind this definition of Newton universal law of gravitation. I will be tell some 2 to 3 sentences of this Newton universal law of gravitation. All and above consideration, including Kepler's law of need, Newton to the formula, his history. Thirdly, that universal gravity, according to and the theory, every object in the universe attracted every of their object is definite the force. Okay, is tell in this chapter. Okay, next one is speed is equal to distance traveled by taken time. Speed, what is the formula of speed? That speed is equal to distance traveled upon time taken. Now next, our fifth point is earth gravitation force. What is meant by earth gravitation force? Very simple definition it is that the earth attracts every object near to itself because the gravitation force. Earth has his gravitation force. You can see in this screen and all information about planets. In this screen you can visible 8 planets. First, second, third, fourth, fifth, sixth, seventh, eighth. There are 8 planets in our solar system. You can see in this screen. Okay. Next day, the center of the mass of an earth is stimulated its center, so the gravitation force on any object due to the earth is always directed toward the center of the earth because of the force, and object falls vertically downward on the earth. Similarly, when without the stone is vertically upward, this force strips to pull it down and reduce its velocity. Due to an constant downward pull, the velocity becomes zero, and while the pull constant to be existed and same start moving vertically downward towards the center of the earth is infinitation. Now next point is that earth gravitation acceleration. Many simple point. A force act on any object reduce its acceleration, thus the gravitation force due to the earth on the body reserves its acceleration. It is called an gravitation acceleration. Once again I will read this definition. The force acting on the object reduces its acceleration. Thus, the gravitation force due to on the earth of an body results its acceleration. This is called acceleration due to gravity, and it is denoted by small g. Now next definition also we have here. In this screen you can visible that Kepler's law of planetary motion, third law screen you can see in this. There is an formula and time also Mercury, Venus, Earth. In our planets, in our solar system, the first planet is Mercury, second planet is Venus, third planet is Earth, fourth is Mars, fifth is Jupiter, sixth Saturn, Nervous and Neptune. Okay, now next screen. Okay, mass. What is meant by mass? Mass is an amount of an matter present in the object. Its SI unit is kg. Also that mass is an scalar quantity. its value is same everywhere, but its value does not change even when we go another planet. But what is definition of the weight? Weight is a force. Its SI unit is Newton. Also, the weight begins a force is vector quantity, and its direction is towards the center of the earth. As the value of G is not same everywhere, the value of an object change from place to place. How this mass is a constant everywhere. Okay. Now all point we has been covered in this today's lecture. I will be show you a small video of this Kepler's law. Okay. Now I will be showing you one video of Kepler's law.
Kepler's first law of planetary motion states that all planets move about the sun in elliptical orbits, having the sun as one of the foci. But what does that actually mean? Well, an ellipse is a shape that resembles a kind of squashed circle. Its foci are 2 points within the ellipse that describe its shape. For any point on the ellipse, the sum of that point's distances to the two foci is the same. The further apart the foci are, the more squashed the ellipse is. If the foci become so close that they are only one focus, you just have a circle. In reality, orbits are never perfectly circular, but we do know that the sun will always be one of the foci of the elliptical path of an orbit. Knowing that the sun is a focus of the planet's orbit can tell us a lot about the shape of that orbit. Kepler tells us that orbits are ellipses, which are like circles with some added eccentricity. But what is eccentricity? How do you figure it out? Eccentricity measures how flattened an ellipse is compared to a circle. We calculate it using this equation. So, what does that mean? Well, A is the semi-major axis, or half the distance along the long axis of the ellipse, and B is the semi-minor axis, or half the distance along the short axis of the ellipse. The equation is a way to compare these axes to describe how squashed the ellipse is. An ellipse with zero eccentricity would just be a regular old circle. As eccentricity increases, the ellipse gets flatter and flatter until it just looks like a line. An orbit with an eccentricity greater than 1 is no longer an ellipse, but a parabola if E is equal to 1, or a hyperbola if E is greater than 1. For example, the giveaway that Oumuamua, the first interstellar comet, was not from around here was that its eccentricity was 1.2. The eccentricity of Earth's orbit is only 0.0167. Kepler's third law states that the squares of the sidereal periods of revolution of the planets are directly proportional to the cubes of their mean distances from the sun. Which, what does that mean? Basically, it's saying that how long a planet takes to go around the sun, its period, is related to the mean of its distance from the sun. That is, the square of the period divided by the cube of the mean distance is equal to a constant. For every planet, no matter its period or distance, that constant is the same number. Kepler's second law tells us that a planet moves more slowly when it's further from the sun. But why should that be? Well, as a planet orbits the sun, it may not keep a constant speed, but it does maintain its angular momentum. Angular momentum is equal to the mass of the planet times the distance of the planet to the sun times the velocity of the planet. Since the angular momentum doesn't change, when the distance increases, the velocity has to decrease. That means when the planet gets further from the sun, it slows down. Kepler's second law deals with the speed of planets orbiting the sun. So, does it tell us at what point the Earth is moving at top speed? The second law tells us that the Earth moves fastest when it's closest to the sun, or at its perihelion. That happens in early January. At that point, Earth is about 92 million miles from the sun. Meanwhile, it's at its slowest in early July, at its furthest point from the sun, or aphelion. That greatest distance is about 95 million miles. That difference of 3 million miles might sound like a lot, but Earth's orbit is so fast that it's actually nearly circular.
Thank you all of you to coming this lecture. I thanks to all of you. Thank you so much. Please subscribe, like to our YouTube channel. Thank you so much. We will see in next lecture. of next date 22 August. Thank you so much.